We've got an old coffee pot on our hot plate. A lot of kinetic energy is being added to the coffee pot, and the heat's being conducted through the metal to some liquid water that's in the bottom of the pot. The liquid water is changing state and becoming gas. You should be able to see the gas. This is a piece of frozen lead. We say it's frozen because it's in the solid state. We're going to put it in with the boiling water. Now, you know from today's lab what the temperature of the water is. Let's see what happens to the state of the metal in the liquid water. The liquid water continues boiling and the solid metal remains solid. What temperature can we possibly attain with liquid water still present? As we continue to add kinetic energy, the water is going to change completely from liquid to a vapor, and then we can start heating beyond 100 degrees Celsius. The liquid water is almost completely gone. We've still got a little bit of vapor left, and at this point, since the evaporation of the water is not carrying away the kinetic energy, what's happening to the temperature inside our pot? We've still got it turned on high. So the eye is adding energy. What can happen to the temperature now? We've been adding kinetic energy for several minutes now, and the piece of lead is finally warming up to the point where little bits of it are ready to turn to liquid. So the solid is going to melt and change phase. You can see how it's leaving a mark on the bottom of the pot. When it starts to melt a little more quickly, I'll turn the camera back on. Alright, there's enough kinetic energy that's been added to the metal so that the vibration at the atomic level of the metal is starting to be greater than the attraction between the atoms. So instead of being just a chunk of solid lead, it's beginning to flow. And so we've got lead at its melting point, changing state from a solid to a liquid. Now, why couldn't this happen when the water was still in the pot? We've added another ingot of lead because we need enough lead to do a couple of demonstrations. We're going to add another ingot yet so that we've got several hundred grams of lead. So I'm wearing some thermal protection so I don't burn my fingers because this lead is hot enough to make your skin peel. The second and third ingots are nearly completely melted. You can see where the sides of the pot are a little bit cooler than the melting point of the lead. Now, when we put the ingot of lead in the boiling water, it went straight to the bottom of the water. And I want to try something else. We've probably got a centimeter's depth of liquid lead in the bottom of this coffee pot, and I have a piece of steel that's about 400 grams. Now, lead and steel have different densities. I want you to look at what we see and tell me which metal has the greater density. If you look, when we swirl this around, what is the steel doing? Now we've got the lead cleaned off the top of the piece of steel, and how many of you figured out what the steel is doing on this lead? You can push it down, it comes right back up. A couple of things I want you to look at. When I pulled out the floating piece of steel, look what happened to the pliers. Why did the lead become solid on the pliers? Another small observation, the end of my stirring stick has become blackened. When you stick it in the lead, the temperature of the lead has caused some sort of chemical reaction to happen on the end of the stick. All right, we've got our melted lead, and we've got some. So our lead is liquid. A lot of kinetic energy is being added. You can see the element of the hot plate that's glowing, adding kinetic energy to the lead through the pot. We're going to pour some of the liquid lead into some liquid water. Now I want you to make a prediction. You know what temperature this liquid water can be without a lid on it. You saw earlier something that was happening with the lead and the boiling water. I want you to predict what's going to happen when we pour the liquid lead into the liquid water. Go ahead and take a moment. Let's write down our predictions. All right, get ready, and I want you to listen and look very carefully. Boys and girls, what happened to the temperature of the water? What happened to the temperature of the lead? What happened to the phase of the lead? Let's go again. Now, I'm going to pour what's left into my ingot pan, my recycled muffin pan, and this is how we're going to store it for next time we need it. And let's chat. I was going to dump out some of our water to get our lead out, and watch what happens when I dump it on the metal the steel that was floating in the lead. It's still very hot, and since it causes boiling, we know it's hotter than 100 degrees Celsius.